And let's go to the next and final
speaker of the conference.
Yeah,
yes,
so
of the day.
The speaker hitting the stage is Nilutpol Kashyap, a ROS developer eager to show us what he has been developing for ROS.
And then Nilutpol, so he's going to show us an interesting method to control robots remotely over the internet by using the Firebase real-time database. So it's another method of controlling robots remotely using the internet, which has been different from the typical ones that we know about using VPNs, or the one that also that Dominique has presented some minutes ago. So it's by using the Firebase real-time database. Nilutpol, are you ready? Let's see, we cannot hear you. Nilutpol, we can see your screen, but yeah, is here is muted? No, yeah, you are muted. Nilutpol.
Yeah, you have to unmute yourself.
Hello.
Yes, that's it.
Now, perfect.
Then you are ready, right? We can see your screen. So let's go. The audience.
Can you hear me now?
Yes, we can.
Yeah, we can.
Can you?
Hello.
Yeah. Okay, so he cannot hear us. You have to uncheck that one.
Ready, right? We can see your screen.
So no, we can hear you. We can hear you, Nilutpol. Are you ready?
Yes, I'm ready.
Okay. Then it's all yours.
Okay, thank you. So hello everyone. So today I will be introducing you to using Firebase real-time database to control robots remotely over the internet. So I think, as you all might know, Firebase is a online real-time database which is by Google, and it can be used for various kinds of applications. So and the speed of the database, the update and read speed is very fast. So I decided why not to try it with controlling robots. So yeah. So today I will be demonstrating using a gazebo simulation. I made the robot myself. So it is a four-wheel drive robot, and it is having a dipper on top of it, which can be controlled using a GUI through Firebase. So here is a small the demo of what we will be experiencing today. Uh, so this is the main workflow. So I'll be using a GUI which will be having certain buttons for like controlling the robot. So the GUI will update that data in the database, in the Firebase real-time database, and there will be one ROS node publisher node, which will be responsible for reading the data from the database, and then it will publish topics. For this project, it will be CMD file for controlling the robot's direction, and a gripper joint position control command topic for controlling the gripper of the robot. And it will be subscribed by the gazebo node for controlling it. So I will just show you. So for getting started, you need to first create a project in the Firebase console. Here is the link. I will show you step by step. So here is the main page for Firebase console. You just have to go for create project. Just enter a name. For this project, just turn off the enable Google Analytics for this project. It will take some time for creating the project. Yeah, and the project is created. So this is our Firebase project. So yeah, you can see in the project it's created. And the next step is, so the creating a Firebase project part is done. You can refer to this video which I have attached if you are lost somewhere. And next is, we have created the project. Now it's time to create the database. And just click on the project. And from the left side menu, you can see real-time database. So just click on real-time database. And click on create database. Just select a database location. There are several, but I'm just selecting the default one. For this project, we can just go for the start in test mode. Start in lock mode provides us various like security measures which can be beneficial for like privacy. But for this demo, I'll just be going for the test mode, which will not be having any security for now. And just click on enable. And the database is created. So as you can see, this is our database. Right now it's null because it's empty. And we can go for the next step. So our project is created, the database is created. Now we need a way to access the database. Just go to this. So we'll just go to click on the left hand side menu and click on project overview. So, and here we need to create add an app to get started. So there are several options. We'll go for the web option. Just register an app. Click on register app. So yeah, now just click on use a script tag. So here are our Firebase credentials. These are the credentials. We'll be using those for like connecting our database to our code. So just keep it like this and we'll go for the next step. So yeah, next step is the Python code. We need to install some Python 3 libraries for our project. So for the GUI, I have used the PyQt5 library, which is used for like creating GUI in Python. So I'll just copy this and install them. Just go to terminal, the shell, and paste those. They will start installing. So yeah, the libraries, Python 3 libraries are all installed. Next, we need to make some edits in our code. So there are two Python codes actually. One is the internet control.py file, which is responsible for like collecting, reading the data from the database and publishing the topics according to the commands which are sent by the GUI. So we'll just update. We just need to update this Firebase configuration details, which we just created in our Firebase app. This will allow us to control, like connect our database to our Python code. So we'll open the file. So yeah, this is the file. As you can see, we need to just update this. And so these are the topics. This is the pub slide one topic, which is responsible for controlling the gripper. And these are some the controls. So it will read the data from the database. So as you can see, this is the main one. This is the parent data. Uh, and it will read the data from it, and it will see for arm control. It will see if it's 0, then it will go for a particular angle of the arm, 0.01 degrees. In I think, yeah, the angle is in radians. If its arm control is equal to 1, it will go for another angle. So it's just for controlling the arm. And here is the condition for controlling the direction of the robot. So it will read if it's if the database is sending FR, it means front. So it will just go. The robot will publish the velocity message, and the robot will start moving forward. And if it's ST, then it means stop. So the robot will stop. And if it's LR, it means left rotate. Similarly, these are the commands, like conditions for controlling the robot based on the data from the database. So we'll start by updating the configuration details. So just go to your Firebase web app and copy this. So yeah, just make some changes. Firebase Python doesn't take columns, and we need to include this in. So yeah, so this file is done. We have included the configuration details for Firebase, and we can now move on to the next step. So the next step is the remote GUI ROS.py file. So the remote GUI ROS.py file is the GUI file. So it will give us a number of buttons and widgets, like a slider for controlling the arm, and it will connect to the Firebase real-time database and update the data on the database. So for this file, we just need to do the same things. Just update the Firebase configuration details, and we'll go here. So this is the remote GUI ROS.py file. We'll open it, and so we just need to change these details. So as you can see, this is the code for the GUI. So I have included several. Uh, this is the arm slider. These are the codes for the front button, the back button. So these are just the buttons, and these are the functions for the buttons. So if this is click me, uh, this is the front button, click. So if the front button is clicked, then it will like update the database, as you can see, and it will update as FR, and
Nilutpol,
it will print as
can you
yeah.
show
Hello.
us? Can you show us the line number 19?
Yeah.
Because I think there is a mistake in there. Maybe it's going to fail then afterwards. 19.
Yeah.
Is that correct?
19. Yeah, it's correct.
How? Is Okay,
Uh,
okay, okay.
behind,
Maybe I'm
yeah,
confusing you. Sorry. Okay.
okay. So as I was saying, this is the back button function. So if the back button is clicked, then it will update the database as the command will update as bk, which means back, and also print a message. So these are the same for the rest of the buttons. This will just update once the button is pressed, and it will update the database according to the command. Yes. And so yeah, this is the change value function, which is responsible for like updating the database with the value for the arm, for the gripper. So it will just update the value according to the slider position, and so I will just update the Firebase configuration details. I'll just copy it from the previous file. So yeah, this part is done. And now we can move on to the next step. So I'll launch the simulation and so show you. So first we'll launch the gazebo simulation. So yeah, here is the gazebo simulation. So and next is the GUI code. I will just run the GUI code. Just open a new terminal. And yeah, so yeah, this is the GUI which I created. It's having several buttons, and this is the slider for controlling the gripper. And next is the publisher node, which will uh,
Uh,
so yeah, now you can see I'm able to control the robot using the GUI. And it's, yeah, as you can see, as you can see, I'm also able to control the arm using the slider. And so yeah, this was for the demo. for the project. And now next I will show you how to add a new feature. So for that purpose I will show you how to add a new button for like making a new function. Like I will show you how to, like, it will go zigzag path. So yeah, let me close this. So yeah, for that, for adding a new button, we first need to update the remote GUI ROS.ui file. So the UI file is the main code for the GUI, which is like run through the Python file. So we just need to add these new features. So this is the remote GUI ROS.ui file. So this is the code. We'll just add our code here. So as you can see, these are all the widgets. So this is one widget which is for the arm slider, the slider for controlling the gripper, and this is another widget which is for the stop button. And similarly, these are all the widgets for from the GUI. So we'll add a widget at the top. We just need to copy this. And yeah, it's done. So this X and Y, these are the positions of the button, new button. So I've just calculated it according to the frame of my GUI, but you can change it according to your own. And this is the width and height of the button. So the widget is placed, and here's the name of the button. It's zigzag button, and its type is Q, push button. And for that, now we just need to add a last line in this code. So this part is Z order. So yeah, so this part is necessary for the z-axis order of our button. So the .ui file changes are done. Next, we'll make some changes into the .py file, the remote GUI ROS.py file. So we'll open the file. So this is the remote GUI ROS.py file, which is basically the publisher node. So these are the buttons already present in our GUI. So we will just add our new button at the last of this. So yeah, it will find the so as you can see, it is find child. So it will try to find the details of our button, like the height, width, position from the .ui file, which is given in here, the .ui file. So and it will also try to match with the zigzag button name, which is already mentioned in the .ui file. And then so this is the function zigzag button click. So whenever this button is pressed, it will like run this function. So we need to add the functionalities of this function here. So this is, we just need to copy this. I'll just add it last. So this is the zigzag button clicked function. So as you can see, whenever this button is pressed, it will update the database with the name. zigzag, which will be read through the publisher node. So yeah, so the changes to the remote GUI ROS.py file is done. Next, we need to change the internet control, the publisher node. We need to make some changes here. So we just need to add this part here. So we will just add for the direction of the robot. So as you can see, already these are already present for front, as I've already explained, stop, left rotate, and we'll, for the new one here. Yeah. So uh, if it's reading as BK, then the robot will start moving back. But if according to our new button, if it's reading zigzag, then the robot will go in a zigzag manner. And I've already included the velocity message. So first we'll go in the left direction, then it will go in the right direction. And so yeah. So changes in the internet controller py file is done, and can now run the simulation again. May see if the changes are done. So we'll just go and repeat the same steps as before for running the simulation. First we'll run the gazebo simulation. So, so gazebo is up and running. Next we'll run the GUI code. We'll run this in a new shell. So now you can see the new button is added. So it will be responsible for like giving the command zigzag, and the robot will start going in a zigzag direction. So next we'll run the publisher node. So yeah, this code is running. Right now the command is stop as default, and we'll test it. So yeah, we'll test our new button. So yeah, so you can see the robot is going in a zigzag sort of direction. Mm, So yeah, it's working fine. So so yeah, I've shown you how to add a button and also use like the explain the functionalities of the new function and everything. So yeah, that was from my side.
Thank you very much.
Yeah,
No, you okay.
thank
So sorry, you go to your concluding remarks. Sorry, I understood that you have finished.
Okay, yeah, it will just. So yeah, I've shown you how to like control the robot over the internet using Firebase, and also to add a new button. So for working with ROS 2, so you just need to like the Firebase part of the code will just be the same. We just need to make some changes in the top ROS part, like the topics, publishing, and all. So we just need to make changes in that, and we need to make some changes in the Gazebo plugin. So in ROS 2, the Gazebo plugins are quite different. So just those parts are necessary, and you can clone the repository into your own system. Here's the link. You'll definitely need to install these Python 3 libraries before working here. And after installing, here's the repository link, and just install it in your Catkin workspace. And yeah, you build the package and it will start working. So yeah, that's all from my side. Thank you.
Thank you, Nilutpol.
Thank you.
Thank you. Thank you very
Thank you.
much. Okay, so remember that you can post your questions in the Q&A section and vote the questions that you like the most.
Yes, and we already have some of the questions there,
Uh-huh.
Nilutpol, so maybe I will be starting with the ones that are here. And there is one question from Ruben that says, he is asking if one can achieve the same results by using a MySQL database. So what is the main difference between MySQL and Firebase?
Okay, so yeah, uh, is my screen visible?
Yeah.
No, but we are putting in a second.
Okay.
Yes, so we can see you now, but not the screen. You have to share your screen.
No, just my video. Okay. So yeah, for the first question, yeah, we can achieve the same using MySQL, but the benefit of Firebase database is that Firebase is a online database which gives us the ability to work with and like control it over the internet. And another benefit is that Firebase is a NoSQL database, so we do not have to go through all the like commands of creating a database using MySQL commands. Firebase is a NoSQL database, so it's very simple to work. As you can already see in the code, like there is no like MySQL commands involved in it. So those two are the benefits.
Very, very good. Thanks. Another question is from Hassan Hariri. Do I need to be on the same network to control the robot via the web app?
No, you can control the robot over the internet. The Firebase database is in the clouds, so you can just control the robot from like one. You just need to run the GUI in one system, and you can run the simulation and the internet control code in another system. Just connect those two systems to the internet, and it will just work fine.
Yes, exactly. This is what you have shown in the demonstration.
Yeah.
So you
Yes.
created a database on one server provider, which is not the construct. So it's another one, the Firebase database. And then by using that, so the web application is connected to the Firebase database, and then the robot is also connected to the Firebase. So you can do this. I think that maybe
Yes.
Hassan Hariri didn't catch the difference. So because the simulation and the web interface, they are both in the same computer, right? This is the one that you are showing, right? And then maybe they think that they are communicating directly, but it is not. The web interface, please correct me, Nilutpol, if I am wrong, but
No, you are right actually.
can you Can you clarify this point? Because I think
Yeah,
that there are some doubts.
elaborate a bit so that people that maybe didn't quite get it, they clear it a bit.
Like, can you rephrase the question, please?
So, yeah, can you describe the structure of the final application? So, who is communicating with who?
So yeah, the first part is the GUI code. Hello.
So,
Am I
yeah,
audible?
so you have the web application, which is the buttons, right? So when we
Yeah.
press the buttons, what happened? Where are those instructions of the buttons going?
So yeah, first part is the GUI code, which is connected to the database, and the date like it is responsible for like updating the database. So it is connected through the internet. It will update the database, and another part is the internet control code, which is responsible for reading from the database. So one part is updating the database, another part is reading the database. So once the data is read from the database, it will just publish the topics based on the commands which are sent.
But for example, you could have the GUI in a computer, let's say in Australia, and that one you press the buttons and it would send the commands to the database, and then the robot, you could have it in, I don't know, in Japan, and it would read the database and move the robot, right?
Yes, exactly.
Okay.
Exactly. Yeah, I think that what confused Hassan maybe is the fact that in this demonstration, both the robot simulated and the web application, they are both running in the same computer, which is your cloud computer that you are doing the demonstration. So maybe it's not very clear to see this transfer of data from the web application to the Firebase database, and then from the Firebase database to the simulated robot controllers.
Okay.
Yes, exactly.
Do we have more time for
Yes,
questions?
yes.
So Juan Sebastián Barreto Jiménez, he says, it would be possible to do this communication that is used with Firebase, but with MQTT, with a broken like ThingSpear or another? I don't know if
you understand
you
this.
understand the question.
We don't understand
We
this
don't understand the
question.
question.
Yeah, actually, it's possible to use ThinkSpeak or other MQTT providers
Okay.
for our code, but like they do not have much more like easily accessible libraries for Python. So like for Firebase, there is a already available several libraries, and the library which I use is called Firebase. So because of the easy access of these libraries, so I think Firebase is quite easy. And moreover, like Firebase is very fast, and also it's free. Like Google provides three Firebase projects for free, and for more you need to purchase, but for three you can easily use it for like demonstration purposes.
And I have one question from myself. This: how much delay have you experienced between the press of a button and the reaction of the robot? How much latency
So
we
yeah,
can expect of this?
so yeah, I've tested the Firebase database with Python, and I've tested with a round trip time, or uh, like what can I say? Uh, pressing a command and the return time. So it's called the round trip time, and I found it at around like somewhere around 300 milliseconds to 400 milliseconds at max.
Okay.
Yeah, so it's good for applications that don't need very fast response, but I mean for sending commands to go forwards or do this task or do this other is more than enough.
Yeah, on a higher level.
Yeah, exactly. So not for control, but yes, for higher level control.
Okay.
Yeah, so
yeah, the other question is not clear.
Yeah. Okay, so I think we're done. So thanks a lot, Nilutpol. Thanks a lot for coming.
Thank you very much.
Thank you.
Yeah. So again, remember that there will be a rating for the speaker. So please rate the speaker. So Nilutpol gets rated, and we are going to say who has been the best speaker 2022 of this conference in just a few minutes. So
well, yes, after we compute all the data.
yeah.
After, yes.
Okay.
that. So now what? Where do we go now?
So now we have a tiny thing to ask you.
Yes. Yeah, so we would like, we still have a few things to finish for the conference, but before finishing, then I would like you, if you can answer this questionnaire with just a few questions. It's about the conference. So how do you feel it? Did you like it? You didn't like it? How was it? Depending on your opinion, of course. So
it helps a lot. The last one we did last year helps us a lot. Helped us a lot to make this one better. So anything that you didn't like, or maybe something that you did like, just say it there, and we hear it. So for that next year, we do it even better.
Yeah, remember that it's anonymous.
Yeah.
So your data is not there. And if you can send you can put, it's very typical 1 to 5 rating. And if you want to put some feedback, that would be awesome also. Even if you don't like it, okay? So you can tell us. Yeah. So at the beginning of the conference, there were some complaints, and yes, we accept them. And always try to improve.
Sure. Okay, so
let's go for it. It's going to take just a few
minutes or so?
1 minute or less, the question.
Okay. So we continue?
Yeah, sure.
Yeah. So ROS developers, all the presentations have been done. Thanks a lot for the speakers, for the wonderful presentations. We know that it's a lot of work and it's a bit stressful also to do a demo live. So you're a brave bunch of people. So thanks a lot.
You.
And now it's the moment to announce the 4 winners of the hashtag, the ROS Dev Day hashtag.
Okay, yes, so we have 4 winners that have been selected by our team, and the clarify the policy for the selection is just because we like it, and that's it. So there is no it's not Miguel and I that we have selected, it's some other people, but
an innocent hand.
Yes. So, and there is no possibility to complain about the decision. I'm sorry. Let's go for it.
Okay, so the first winner is Johnny Polanen for this fantastic setup with the pizza. We loved it.
And the projector.
The projector is amazing.
Awesome. It's a very good idea because you can have your computer and also the projector. It acts as another screen, and then you can do both things at the same time, watching the presentation of the speaker and then also doing your part. It's excellent.
So congratulations, Johnny.
So you will get a t-shirt like this one.
Yeah.
What else?
The next one is Supreet Kumar K. And it's obvious why he has won. So the amazing screen, the setup, I think it's the perfect setup for this conference.
Yes.
Amazing.
Awesome.
We loved it. So
awesome.
Congratulations, and you'll get a t-shirt like this one.
Yes. Great. Next one,
Marco Pedretti. So
Marco, so you won a second t-shirt, right?
So he at the end, when we do like 20 conferences, then he'll have all
of them packed.
All of them.
There. Congratulations,
Marco. And the last one, Brett Aldrich. So it's obvious also why he's our favorite hacker of the conference. I mean, he's spending more energy than a whole city or something with so many screens.
So many screens. Yes, take care of the carbon.
Okay, congratulations, Brett.
Okay, great. So those are all the 4 winners of the t-shirt because of the excellent pictures that they have taken about how they are living the ROS Developers Day. Excellent. Now,
so, next we will have the 3rd ROS Awards ceremony. We are going to announce the best ROS software, the best ROS robot, and the best ROS developer of the year. So See you in a few
in a few
minutes.
minutes.